We had our short videos, and now for a bit of a lengthy one. We are going to do what we can to both sides of this equation, okay? And, of course, we could do it on the utility, and we will, but we want to do this algebraically, and it's important that we have these skills. So we know that the sine of 2x, we're thinking about this side right here. The sine of 2x is equal to 2 sine x cosine x. So if we substitute in 2x for x for here and here, then we can say that the sine of 4x is equal to 2 times the sine of 2x cosine 2x. Maybe another way of saying this could be to say 2 times the 2x, like that. How about that? And we could say that's the same thing as the sine of 4x, right? Okay. So once we say that, then we have to keep going, and we have to say, all right, this is equal to 2 times, what is the sine of 2x? Well, now we can just say 2 times the sine of x cosine x and get it down to just that. But then I have to say the cosine of 2x is cosine squared x minus sine squared x. All right. And now I think I'm going to go ahead and multiply that out, and I'll say 4 sine of x cosine to the third x minus 4 sine to the third I was supposed to say cosine x. Okay, so that's that part, okay? That's the sine of 4x so far. Okay, for the other side here, I'm going to say minus 2 sine, maybe, sine of 2x. And I'm going to say that is equal to, negative 2 times, it's just going to be 2 sine x cosine x, right? Okay, and that's going to be negative 4 sine x cosine x. All right, so let me write this again. Let me write the whole thing again. I have 4 sine x cosine to the third x minus 4 sine to the third x cosine x is equal to the other side, which is negative 4 sine x cosine x. So I've taken everything out to its extreme position here, and now I realize, hey, I could factor something out of both of these, right? And so I will. I can factor out, let's see, what color shall I use? Let's factor out 4 sine x cosine x. And I realize we're kind of going around in circles a little bit here. Cosine squared x minus sine squared x. Probably didn't need to do all this just to say this. And then let's add the one on the right to the other side. And then we'll be equal to 0, right? Okay, so we moved it over to the other side. We move this over here. And now, let's see, what can we say? Well, we can further take this out, right? We can say 4 sine x cosine x times cosine squared x minus sine squared x. And this is just plus 1 now, right? Because I took the 4 sine x, I took this out. And when I take it out, I'm left with a 1 behind. Okay. So now I'm thinking, let me write this again. I'm trying to show a lot of my steps here. Maybe I could skip some of these, but I'm going to put it out in all its painful details. 1 is the same thing as sine squared x plus cosine squared x, right? From the Pythagorean identity. Right, we remember that. Sine squared x plus cosine squared x is equal to 1. The main Pythagorean identity over there. Okay. And now at this point, the sine x squared are going to cancel. And I'm going to have 4 sine x cosine x times 2 of these cosine squared x's. And when I multiply it all together, I'm going to have 8 sine squared x cosine to the third x is equal to 0. Okay, so now there's no adding, subtracting. There's probably a faster way to get here. There probably is a faster way to get here. But anyway, this way gets us here. And now we're going to think about two things. When is sine x equal to 0? Well, x would be equal to, well, sine starts at 0, doesn't it? And then it also happens again when x is pi. So those are two answers right there. Okay? And then what else can we say? Well, let's do the cosine cubed x. Cosine x cubed. You know, it doesn't matter if I cube it. It'll still be 0. So if I say this, you know, cubed, that's fine. It's the same thing. When is cosine x equal to 0? Well, cosine x equals 0 when x is equal to pi over 2, right? That'd be 0. And if I cube it, still 0. And also at 3 pi over 2. So those are my answers. Oops, let's see here. Oh boy, what did I do there? Okay. Here we go. And I will provide a graph that shows that this is so. This is so. Yours is nice. Just remember for yours that you're going to say sine 2x plus cosine 2x times sine 2x plus cosine 2x. Just multiply that out and see how things go. And I think you'll be pleasantly surprised. Yours won't be as weird as mine is. Okay. And look for the graph. I think that'll maybe, well, at least it'll verify what we did here.